And we can multiply complex numbers as well. And using, oops, I'm using the wrong tool. Using the property that I squared is equal to -1. For example, if you're given the square root of -49 times the square root of -9. Now, if we simplify the square root of -49, right, we could rewrite it as the square root of -1 times the square root of 49. Remember, the square root of -1 is equal to I, and the square root of 49 is equal to 7. You could do something similar with the square root of 9. Multiply the square root of -1 times the square root of 9. And then change the square root of -1 to I, and the square root of 9 is equal to 3. Right. And so all of these are really multiplied by each other. You have I times 7 times another I, times 3. And so that would leave you with, when you multiply 7 times 3, 21. And you can multiply I times I. Just like with variables, you would add exponents. The unwritten 1 is an exponent for each, so 1 and 1 would give you 2, so you'd have I squared. 21 I squared. And then recall that the I squared is equal to -1, so that your answer is -21. So as I said, the I squared equals -1 will be necessary. You can multiply binomials using FOIL or the distributive property to multiply them. I have here 1 plus 3i times 1 minus 3i. Let's say you want to use distributive property to multiply these. You could also use that FOIL, first, outer, inner, last, if you remember that. With distributive property, I'd multiply the 1 plus 3i times the 1 that comes first, and then also multiply it by 4i. Oops, let me find my eraser. I'm writing the wrong thing down. In fact, let me backtrack on this. I'm going to put the 1 first, so it's a little bit easier when we go to distribute just to read through. So this would be the 1 plus 3i times the first one, and then we have 4i times 1 plus 3i, and we'll distribute like that. And then distribute again. 1 times 1 plus 3i would just be 1 plus 3i. We can remove parentheses. And now you'd have to remove parentheses and distribute the negative or minus 4i. So the 1 times the minus 4i is negative 4i here, minus 4i. And negative 4i times the 3i will give you negative 12i squared. We can combine the two middle terms here, the second and third term, because they both are like terms. 3i minus 4i would leave you with minus 1i. We just write minus I. So we have the 1 from before, minus I, and then minus the 12. I squared is -1 again. So I'll write that as times -1 now. And this becomes 1 minus I, -12 times -1, make that plus 12. And we can combine the 1 and 12. 1 plus 12 is 13. So we'd end up with 13 minus I if we put this in the a plus bi form.